So going back to those three parameters that we use to define ellipsoids, the semi-major axis, semi-minor axis, and the flattening. And so I've got a table here that shows three different ellipsoids. So you've got the Clark 1866 ellipsoid, GRS 80 ellipsoid, and WGS 84 ellipsoid. And I'm sure by now you would have heard of at least one of these two. So WGS 84 or GRS 80. So preferably, I prefer if you've heard of both by now, but they are examples of global geocentric ellipsoids. So global geocentric ellipsoids, global in the sense that they provide a good representation of the entire surface of the Earth, and geocentric meaning that they take the center of mass of the Earth as the origin of the ellipsoid. And then we have and on the table here, we've got a semi-axis, so the semi-major axis, you've got a semi-minor axis, and you've got the flattening. And as you see, the flattening is a ratio, and I'll show you actually how to calculate it in a minute. So this table, oops, back. So this table has, if you notice, they've got some streaks here. So there's little stars. So they are the defining parameters for the ellipsoid. And remember how I said in the previous slide that you need a minimum of 2 parameters to be able to define your ellipsoid. So in these 3 examples, the defining parameters that were selected were given by that little star in the center there, or the end there. So for example, the Clark 1866 uses the semi-axis and the semi-major, semi-minor axis to define it. GRS 80 uses the semi-major axis as well as the flattening to define it. So it doesn't really matter, as long as you have 2 parameters, you can actually calculate the others. And here's how to calculate them. So we've got this nice, easy relationship between the parameters. The flattening, which it gives us an idea. Obviously, it's a ratio of how much flattening is actually present in that ellipsoid. If you take the ratio between the semi-minor axis and the semi-major axis, 1 minus that ratio gives you the flattening. It's generally a very small number. So just going back 1 slide, you see it's 1 over that large number here. So flattening is generally a very small number. Another important calculation that we need, or calculation that we need to derive, is a concept of something called the first eccentricity. And then also sometimes you see a second eccentricity. So the reason I'm bringing these up here now is they might not make sense as they are, but once we get into more complex calculations when it comes to the ellipsoids, you need to be able to use the first and second eccentricities in some of these calculations. But that's not difficult, because if you have a minimum of 2 parameters, you can actually calculate the first eccentricity or the second eccentricity. So you see this little E symbol, that's your first eccentricity, and then you've got a little apostrophe there, that's your second eccentricity. And the way to look at the first and second eccentricity is there are actually 2 separate equations. So this is the first equation, and this is the second equation. Okay, so the eccentricity is equal to this relationship here. So you've got a squared minus b squared all square rooted divided by a, and we know here that a and b, it's just a matter of going back and looking at the table a and b and just putting these numbers in. So to calculate the eccentricity, you can either use the semi-major and semi-minor axis, or if you don't have one or the other, you can use the flattening. So the relationship, or the way to calculate it, would be the square root 2f minus f squared. So again, depends on what you have. So if you are given a, going back, so if you are given a semi-major axis and a flattening as the defining parameters, then you might need to use the flattening in this case because you don't have the semi-axis minor. So just use your judgment and decide which one to use. But if all three are given, obviously it doesn't really matter. But here it's just telling us that the defining parameters for the ellipsoid are these particular ones. So if I give you an example and I ask you to calculate the semi-major, the first eccentricity or the second eccentricity based on the parameters, then you have to make your judgment to see which one you would actually use. So similar with the second eccentricity, you can either use the relationship again. So if you know the semi-major axis and semi-minor axis, you can actually use that relationship. But let's say that you don't have that and you've only got the flattening, then you can actually calculate the first eccentricity from the flattening and then take that and input that into here. So it's also another way to calculate the second eccentricity. Don't worry too much. So once we start to see examples later on in the course, you can learn how to use them. So here's a calculation example using the parameters for the Clark 1866 ellipsoid below. Calculate the first eccentricity. So in this case here, I would choose these two as the defining parameters based on the little star that you see here. So based on that, I would ask you to calculate the first eccentricity. So it's quite straightforward. All you do is you say, this is the equation that you would use because you already know the first and second, the semi-major and semi-minor axis. Okay, so if you input these values in here and you can tell me what comes up, that would be good. So in your own time, you can practice doing this calculation and I'll post the answer out for you as well, so just so you can check.